These are the applications of aspirin. Aspirin, also known as acetylsalicylic acid, is a synthetic carboxylic acid. The word aspirin is derived from the prefix "a" for acetyl and "spir" from the Latin name spirea for the meadowsweet plant from which this was first derived. Aspirin was first sold in 1899 after Felix Hoffmann, a German chemist, developed a viable commercial way of synthetically deriving this. Salicylic acid and sodium salicylate were largely used as analgesics, but had unintended side effects, and chemists synthetically modified this to produce aspirin. Here's the chemical structure of aspirin. Its IUPAC nomenclature is 2-acetoxybenzoic acid. The root of aspirin is a benzoic acid and an aceto group located on carbon 2. It has a density of 1.4 grams per centimeters cubed, a melting point at 136 degrees Celsius, and a boiling point at 140 degrees Celsius. It is soluble in water at 3 milligrams per milliliter at 20 degrees Celsius. It's synthesized by the way of an acetylation reaction of salicylic acid with acetic anhydride. This is acid catalyzed with sulfuric acid or phosphoric acid. Here's the general reaction mechanism. First, sulfonation of benzene occurs, creating benzene sulfonic acid. Then, the benzene sulfonic acid is neutralized to create this sodium phenolate. Here, a kolbe-schmitt reaction is taking place. The negatively charged oxygen creates a double bond with the carbon it's attached to, and then the double bond right here creates a bond with the carbon of carbon dioxide, and the lone pair moves to this oxygen. Here, this double bond between carbon and oxygen takes the hydrogen at carbon 2 and makes a double bond between carbon 1 and carbon 2. Then, the negatively charged oxygen that was a part of the CO2 group takes a hydrogen from the water, and then the electrons go to the oxygen. This creates salicylic acid. Then, acetic anhydride and phosphorus are used to create this ion here with a positively charged oxygen. Then, the alone pair from the phenol group bonds with the carbon that is part of this ion here. Then, the deprotonated acid takes a proton from the positively charged oxygen, and then the electrons go to the oxygen. The newly regenerated acid is deprotonated by the oxygen next to the carbonyl group. The deprotonated acid takes a hydrogen from this hydroxy group and then forms a double bond between the oxygen and the carbon. This is when the aceto group leaves. The products are acetylsalicylic acid and acetic acid. Aspirin is one of the most widely used drugs. It treats pain, reduces fever, and headaches. In low doses, it can be used as a regimen to prevent blood clotting and reduces the risk of ischemia, the low presence of blood near an organ, and unstable angina, which is heart pain. In high doses, it can treat the symptoms of rheumatic fever, rheumatic arthritis, and other joint diseases, and also pericarditis. Aspirin shouldn't be given to children under the age of 16 because it can cause Ray's syndrome. Low doses of aspirin can be given to people with retinopathy or diabetes to help treat symptoms, and also for people who are taking antihypertensive drugs, which stop high blood pressure. Taking aspirin daily can also increase the chances for pregnancy. The most common side effects of aspirin are an irritation to the stomach, indigestion, and nausea. Less common side effects are vomiting, inflammation of the stomach, stomach bleeding, bruising, worsening of asthma symptoms, and in rare cases, it can cause hemorrhagic stroke. Aspirin is a versatile drug that can be used to treat many ailments. Since it is relatively simple and cheap to produce, it has become one of the most widely used analgesics. And our references.